All right, my question is, if an image can exist with a concave lens, if P, the object distance, is equal to F, the focal length. This question is based on the fact that for converging lenses and concave mirrors, if P is equal to F, the image does not exist. So just like the basis behind the fact that it cannot exist with a converging lens, if that's our lens, and this is the focal length, if the P, the object, exists here, we can draw one ray through the lens, and the focal length on the other side. It'll pass through there. And the other ray is going to pass through the center, and being parallel, they'll never intersect and they'll never come together to form a real image. We could even look at this mathematically. Where we can say that the focal length equals 10 centimeters, and that the object distance, which is equal to 10 centimeters. So 1 over 10 equals 1 over 10 plus 1 over q. For 1 over q, you get 1 over 0, and you cannot take the inverse of 1 over 0. It just doesn't exist. So that's just mathematically a way to see that this drawing is correct. But with a concave lens, let's say our focal length still is 10 centimeters, and P is equal to this as well. We can draw one ray coming in, and we can see that at the convergence of these two rays, we have an image that formed on this side of the lens. And so we can look at this again mathematically using the same equation. And this time, and this is the point where people could make an easy mistake. For the focal length, it's actually negative, 1 over negative 10. That's just inherent property of concave lenses. And then 1 over P is still 1 over 10 plus 1 over Q. So, for 1 over Q, we get negative 1 over 5. So Q equals negative 5. And that tells us that this image is formed halfway between the focal point and the lens itself, and it's smaller.